Here is the exercise. A block of information is transmitted repeated over a noise channel until an error-free block is received. That n is greater than 1 be the number of blocks required for a transmission. So we define the following sets. Number 1, A. The event A is the n is even, and B is a multiple of 3, and the C is the number of blocks is less than or equal to 6. And we assume the probability of requiring one additional block is half of the probability without the additional block. So here is the probability. Then we determine the following probabilities. So part A. The probability A is the block is even, so the probability of A actually is probability of M is even, which is M equals the K should be like 2, 4, 6, ... which means 1/2 when K equals 2, here is 2. When K equals 4, when K equals 6, when K equals 8 to infinity. And from the exercise 1, the homework 1, we know this summation is the ratio 1 minus the ratio in the denominator. Here the answer is 1/3. Now we want to find the probability of B. The probability of B is M is a multiple of 3, which means K is 3, 6, 9, 12, and so on. So it's 3, 6, 9, and so on. And this summation, again, we put the first term divided by 1 minus the ratio, which is 1/7. Part C. Probability C. Let's see the probability C. Probability C is M less than or equal to 6. Less than or equal to 6. So, which is N is less than 6. That means K is from 1, 2, 3, 4, 5, 6. So it's 1/2, 1, 2, 3, 4, 5, and 6. And the answer is here, 63/64. And also we need to find the probability of a C complement, which is easy because the C complement is just 1 minus the probability of C. Which is 1 over 64. Now part B. We want to find A union intersection B. So the probability of A intersection B. A is even and B is a multiple of 6. So the intersection will be the M is a multiple of 6. So it's 6, K is 6, K is 12, K is 18 to the infinity. And this answer is 1 over 63. And probability of A subtract B, which means n is an even positive integer and not a multiple of 3. But from the definition, we can also know that this is also the probability A minus probability of A intersection B. Well, A subtract B is this area. So it is the probability of A minus this area, which is easier to compute. So this is 1/3 minus 1 over 63, which is 20 over 63. And how about A intersection B intersection C? Because C is less than or equal to 6. So finally, the probability is just M equals 6. For example, A is 2, 4, 6, 8, dot, dot, dot. And B is multiple of 3. So it's 3, 6, 9, 12, dot, dot, dot. And C is 1, 2, 3, 4, 5, 6. That's it. So the common number is 6. So it's 1 over 2 to the 6. It's 1 over 64. Now part C. If I want to find the conditional probability, A conditional on B. First of all, we just write it down. The formula is probability A intersection B divided by probability B. We have those answers, so the final answer is 7 divided by 63. Since we have already found each probability and the union and the intersection of the probability, so here it is easier to find the answer. Just plug in. So the probability of B condition on A is B intersection A divided by probability of A, which is 1 over 63 divided by 1 over 3. So it's 1 over 21. Part D. The probability of A conditioned on B intersection C. First, by the definition, we know the numerator will be A intersection B intersection C, and the denominator will be B intersection C. So for the numerator, we know the answer is 1/46. And how about B intersection C? B intersection C is only, M is only, K is only 3 and 6. So we only consider this two number, which is 1, 9. Because B is a multiple of 3. So it's 3, 6, 9, 12. But C is less than 6. So C is 1, 2, 3, 4, 5, 6. So the intersection number is 3 and 6. Similarly, the probability of A intersection B conditioned on C. Again, the numerator will be the same. And the denominator is just probability C, and which is easier, it's just 1/63.